Hey everyone! Today we'll start diagnosing the misfire and no-start conditions in my 1992 Acura Legend. Stay tuned. The misfire condition in my 1992 Acura Legend started out as a very slight misfire a couple years ago, but it's since progressed into a horrible stumble to where I can no longer drive the car. I actually haven't driven it for almost 2 years. Recently the car also would not start when I went to warm it up, so I decided to resolve these issues once and for all. Since the Legend is running very rich and the only way I can get it started is by spraying starting fluid into the throttle body, I decided to just pull it into the garage using my floor-mounted winch. The no-start condition itself appears to be fuel related, so I thought I'd look at both the electrical and mechanical components of the fuel pump circuit. Starting with the electrical side, I pulled out a circuit diagram from the electrical troubleshooting guide for the 92 Legend. You can see here that it's a very simple circuit composed of the 20 amp fuse at location 22 in the underdash fuse panel, the main relay, which we've already tested in another video, and the fuel pump. The ECU, or electronic control unit, and the battery are also major components. So let's start with the battery. This battery is actually a warranty replacement that I picked up a few weeks ago, so it should be in pretty good shape here. We're going to actually methodically walk through testing all these components, even though it may seem like overkill in a few instances. I have my multimeter all ready to go, and what I've done is set the multimeter on the DC voltage setting. I'm going to touch the red probe to the positive terminal and touch the black probe to the negative terminal, and what the multimeter will do is display the difference between those two. So I should have around 12.6 volts at the positive and around 0 volts at the negative or ground. And it looks like our reading is 12.75 volts, so we've confirmed that we have a healthy battery, and we'll just move on to testing out the fuse. Typically we can just skip over the fuse if we hear the main relay click on and click off, and we also hear the fuel pump running. But I also want to check to see how much voltage we're actually getting at the fuse, because we could be losing some voltage coming from the battery to the fuse, and that could affect our fuel pressure. I'm going to first pull the fuse from the panel to take a close look at it. And as you can see, there's no break in the wire, so the fuse is just fine. So I put the fuse back in, and what I'm going to do next is just measure the voltage at the fuse. So I have the black probe hooked to a metal part of the car to act as our ground, and then we'll just touch on the fuse with the red probe to get our voltage. I'll put the key in and turn it to the on or run position, and you should hear the main relay come on and possibly even hear the fuel pump running. And it looks like we're measuring about 12.19 volts at the fuse. Now, while we've been doing all this testing, we could have lost some voltage at the battery. So a more accurate way of checking the voltage differences between the battery voltage and the fuse voltage would be to do a voltage drop test. So I'm going to put a link in the description below to a series of videos that was done by Real Fixes Real Fast on voltage drop testing, and I encourage you to check it out. It's a very good series of videos. I'm going to do a quick voltage drop test sample here, and so what I've done is hook the multimeter's red probe to the positive battery terminal. Then I'll touch the black probe on the fuse. The multimeter should display somewhere around 0.55 volts, which is the difference between the two voltages. From what I've read, a healthy circuit should drop no more than about 0.5 volts total, but I've also read that some of these older Hondas drop quite a bit of voltage. So with the black probe on the fuse, I'm going to go ahead and put the key in and turn it to the on or run position. And you can see there 0.56 volts, so that's the difference between our battery and our fuse voltage. Next, we're going to check the incoming voltage at the main relay's gray connector. I have the black probe hooked to a body ground, and a red back probe on the black-yellow wire in the connector. I'll turn the key to the on or run position. And we got around 12 volts. Okay, now I want to check the outgoing voltage from the main relay to the fuel pump. So I have my red back probe on the black-yellow wire in the brown connector. I'll turn the key to the on or run position, and we should see around 12 volts for about 2 seconds before it drops back down to near zero. This just allows the fuel pump to pressurize the system so the car can be started. So somewhere around 11.4 to 11.6 volts before it dropped back down to near zero. Our voltages appear to be somewhat in line with expectations at this point, so I've moved on to the fuel pump. To get to the fuel pump, I've removed the back seats and some of the trunk lining. For brevity's sake though, I'm not going to explain how to do that here, and I may do a follow-up video at some point. I've removed the metal cover for the fuel pump, and I've also removed the white connector cover to expose the wires we need to test. I have a red back probe on the black-yellow wire, and a black back probe on the black wire. The black wire is our ground, and what I'm going to do is turn the key to the on position and see what our voltages read. You should hear the fuel pump running, and it looks like we peaked at somewhere around 11.3 volts. It appears that the fuel pump's electrical circuit is functioning normally, so we'll just keep those voltages in mind and move on to the mechanical test.